where we have to look into, call it de Moivre's theorem. De Moivre's theorem. De Moivre's theorem. So mostly de Moivre's theorem are applied in mostly in polar form when we want to do division of complex numbers and multiplication and raising let's say a complex number to the power of some. So let's say for an example we are given z1 which is equals to, let's say it is in polar form, r1 augment theta 1 and z2 which will be equals to r2 augment theta 2. So let's say for an example we must divide z1 by z2. So if we're dividing z1 by z2, the formula states that the Moivre's theorem says that we'll divide. Well, let's start by dividing. Let me write augment theta 1 divided by r2 augment theta 2. So the Moivre's theorem states that we are going to divide the modulus r1 by r2 and we are going to subtract theta 2 from theta 1. So we say theta 1 minus theta 2. That is the Moivre's theorem. So when we have division of complex numbers in polar form, we divide the modulus and subtract the augment, the angles. If we have to multiply z1 by z2, in a case, let's say z1 by z2, we are going to multiply r1 by r2. When it comes to your augment, theta 1 will be added with theta 2. So it's theta 1 plus theta 2. So you can remind yourself by using like type of exponential laws that if, let's say, the base are the same, you're dividing, you subtract. If, let's say, you're multiplying, the base are the same, you add, but you add the augment thetas. So that is multiplication of complex numbers. So the other one, if, let's say, we have, for an example, let's say let's say complex number z, which was, let's say, to the power of n. The Moivre's theorem states that, let's say, for example, we have r augment theta, all in all to the power of n. If we have a power bracket, it's like you multiply the exponents and raise the other one. So we're going to say r to the power of n multiply theta 1 by n. So it's n times theta, or theta times n. Going to raise r, the modulus to the power of r, n to say, then theta multiplied by n. Theta multiplied by n. So that is the Moivre's theorem. So I want to take one problem. Let's say, for an example, a question says that, let's say divide, yeah. Divide in polar form. So divide in polar form. I want to choose an example. Let me just use this and say it's number 1. Let's say we have 1 minus j all divided by 2 plus 5j. And then if, let's say it says divide in polar form, and then the final answer leave it in rectangular form. So there's a few steps that we have to apply. We have to divide 1 minus j over 2 plus 5j, dividing the numerator. So here we are not dividing, we must not use the conjugate method. We must try and divide in polar form, which means we must change the numerator into into polar form. How do we do that? It means with the first one, treat it as negative j and say it's z1. So if z1, you must try and find r1. You must try and find r1. And r1 must be a squared plus b squared. So we know that the coefficient of j, it is b, and then our real part is 1. So we have 1 squared plus b is negative 1 all squared. Then our modulus is, it's root 2, isn't it? It is root 2, isn't it? Use calculator. So 1 squared plus minus 1 squared is root 2. So we even need to find the augment theta. So theta 1 is equals to. So I should have even mentioned that try and do a plotting on an Argand diagram so you can see where it falls or it lies, the angle. If let's say I went to the right 1 unit, I've went down because it's negative 1 unit. So which means the angle we'll be looking for, it will be from 0 to there. So which means we'll be on the fourth quadrant. So if we're in the fourth quadrant, we know that it's at 360 minus. If I mentioned that yesterday. Therefore, it must be arctan. It is b over a. The formula to get theta, it is b over a. So what is b? B was minus 1, right? So, but why did I say there we're going to use the positive ratio? So 1 over 1. So this 360 minus answers the negative that we're going to have, because in one of the exercises said that if the ratio of tan theta is equals to, let's say, negative b over a, we are going to project at 360 minus the acute angle there. So what is our theta 1? 360 minus tan 1, it's 3. So it's 15 degrees. So I hope you see it's true. We're in the fourth quadrant there. The angles are greater than 270. So we need to even solve now the second one. Solve the denominator one. So at least in polar form, in fact, let's express it in polar form. Our z1 is equals to r, it is root 2. Augment theta there, 315 degrees. So we express it in polar form. So now we need to do that with z2. Z2 is equals to 2 plus 5j or j5. We need to convert to polar form 2 before we divide. So we need to find now R2. R2 will be equals to a squared, which is 2 squared plus 5 to the power of 2. Our modulus R is equals to 5. So it is 20 root 29, right? Root 29. Okay, so let's look at the tan theta there. What's happening? Tan theta, it is a positive ratio, isn't it? So B, it is 5 over 2. So which means the ratio that we're having is positive. At least the solution that we're looking for, it will be where on the first quadrant. So, but please just do projection of your complex number. We go 2 units to the right, 5 units up, because coefficient of j is positive. So I hope you see that the angle we're looking for is just the acute angle. It lies in the first quadrant. So there's no need to go and check if theta is negative where or positive where. The theta there. So it lies in the first quadrant. So which means theta will be just equals to arctan, the positive ratio. So 5/2. So it's arctan 5/2. It's in the first quadrant. All angles in the first quadrant are acute angles. So it's 619. 68,1 degrees. That is our augment theta. So we can express our Z2 in this format. R, it is 29. Augment theta 68.19 degrees. So we have our Z1, Z2. So we can divide the complex numbers in polar form. In polar form. So in polar form, let us divide. Now our final Z, it will be equals to, so it's Z1 divided by Z2. So Z1, we said it is, it's root 2, augment 3, 1, 5 degrees, all divided by root 29, augment 6, 8.19. So the answer will be equals to, so just divide root 2 over root 29 because we're dividing. So I know it will be inside the root 2 over 29. It will be 2 over 29. Yeah, root 2 over 29. It's or root 58 over 29. Yeah. Over 29. That is root 2 over 29. Okay, and now we need to subtract 315. We subtract 68.19. Because we are dividing, we subtract the angle. So it's 246. 81. Okay, degrees. So if they said leave your answers in 3 decimals, please you'll change that root into 3 decimals. But the question that I asked, I said, let's leave the answer in rectangular form. Let's leave the answer in rectangular form. So how will we leave that in rectangular form after dividing? We are going to use this formula that a complex number expressed in polar form R into cosine theta plus J sine theta. This will help us to convert to rectangular form, but though is in polar form. So when we substitute, R we said is root 58 over root 29. Okay. Or it was root 58. Okay. So it's root 58 over 29 into cos 246.81 minus J sine 246.81 close bracket. It's obviously still visible. So you are going to say root 58 over 29 times cos 246.28 and state the answer. What do we get? Show something over 29. Is it not negative 3 over 29? Root 58 over 29 multiplied by cos 246.81. It's negative 0, 0.9. Okay. And therefore the other one must be negative root 58 over 29 multiplied by sine 246.81. Root 58 over 29 multiplied by sine 246.81. So the answer is equals to negative 0.24. So negative 0.24 for J. I hope we have the same answer. Okay. So I just want to pull out something from the one that we did previously. It was the same answer, I think. Yeah, same problem. You just want to confirm the two here. If you check if they're not the same answer, these two. These two. To confirm if they're not the same answer. So negative 3 over 29 is negative 0. Negative 0.013. Okay, let me confirm if the same problem. 2 plus 5j